Good morning class, how are you all? So we have been learning about HCF and LCM, right? So today we'll learn some more interesting facts about HCF and LCM. See this example. Find the HCF and LCM of 25 and 45. You can either use the prime factorization method or the short division method to find the HCF. So I'm going to use the prime factorization method here. So let's see the HCM of 25 and 45. So let's first factorize 25. So how do you factorize 25? 25 when prime factorized gives you 25 equals 5 into 5, and 45 prime factorized gives you 5 into 3 into 3. Now how do you take the HCF? You have to take the common prime factors and you take one each from the set of common prime factors. So look here, see the common prime factors here, which is it? Only 5 is common to both of these numbers. So let's take 5 from this set, and hence the HCF here is 5. Let's take the LCM. For finding the LCM, you have to take the product of one of the prime factors from the common set, then all the other non-common prime factors. So from here you take 5, then this 5, this 3 and this 3. So that gives you the product, how much? 225. So the LCM here is 225 and the HCF is 5. Now let's take the product of the two given numbers. What is 25 into 45? Let's take the product 25 into 45. Let's multiply the ones first. So 5 5 is 25. 2, 5 into 2, 10 plus 2, 12. 4 5s are 20. Then 4 into 2, 8 plus 2, 10. Put a 0 here. So what is the product? It is 1125. Now let's take the product of the LCM and the HCF. So that is 225 into 5. What is 225 into 5? 5 5s are 25. A carry over 2. 5 into 2, 10 plus 2, 12. A carry over 1. 5 into 2, 10 plus 1. It's 11. So here we got the same product, 1125. So multiplying the given numbers and multiplying the HCF and LCM of the given numbers gives you the same product. So we can say the product of two numbers is equal to the product of their HCF and LCM. Clear? Now, if that is the case, if you know the product of two numbers, the product of the LCM and HCF of two numbers and one of the numbers, can we find the other number? Look at this example. The HCF and LCM of two numbers are 9 and 504 respectively. If one of the numbers is 63, find the other number. So what are we given? We are given the HCF and LCM. What is the HCF here? Here the HCF is given as 9 and the LCM is given as 504. We are also given one of the numbers. One of the numbers is 63. What is the other number? So let the other number be A. So from the question we know that A, one of the numbers, into the other number 63 is equal to the product of the HCF and the LCM, right? Now if that is the case, we can write A equals 9 into 504, this part, divided by, we are bringing this 63 here to the right hand side. So this 63 goes to the denominator. So we can write A is equal to 9 into 504 divided by 63. So how many 9s go in the 63? See here, 7 9 goes in 63. So we can cancel these two numbers by dividing 9 from both these numbers. So here we get 504 divided by 7. What is 504 divided by 7? It gives you the quotient 72. So that gives us the other number. So the other number here is 72. Now, we have already learned to find out the HCF and LCM of smaller numbers like 2-digit numbers. So how we are going to find out the HCF and LCM of bigger numbers like 3 and 4-digit numbers? See, there is a method called the Euclid's algorithm. Euclid was a Greek mathematician and he has formulated an easy way to find out the HCF and HCF of bigger numbers. See, here you have 3 numbers. Find the HCF of 210, 525 and 350. So before we move into that question, let me show you one simple example. You have 2 numbers 6 and 12. What is the HCF of 6 and 12? Shall we use the short division method here? See, how do you do the short division method? You divide, you write both the numbers in a grid and you see the smallest possible prime factor for these numbers. Shall we take 2 here? Yes, 2 can divide both these numbers completely. So what is 6 divided by 2? Gives you 3. 12 divided by 2 gives you 6. Again, we can use 3 here to divide both these numbers completely. So here it becomes 1. 3 divided by 3, 1. 6 divided by 3 is 2. So here you have the prime factors and you take the product of the prime factors. So 2 into 3 gives you 6. So the HCF of 6 and 12 equals 6. See, according to Euclid's algorithm, you can do this in a different way. I'll show you how. Instead of doing the short division method, which were the numbers 6 and 12, you can divide one number by the other number. So here you can do 12 divided by 6. What is 12 divided by 6? How many 6's go in 12? It is 2. So here you do the division and you see the remainder is 0. When you get the remainder is 0, that divisor is going to be the HCF of the 2 given numbers. So keep this in mind and let's do the question we are given. So what was our question? Find the HCF of 210, 525 and 315. See, first we are going to find out the HCF of the first 2 numbers. Then what do? Then we are going to find out the HCF of the third number and the HCF of the first 2 given numbers. So how can we find out the HCF of the first 2 numbers? We can divide the one number or the second number by the first number. So let's see how we can do that. How many 210s will go in 525? Let's do 2. So 2 into 210 gives you 420. So 5 minus 0, that's 5. 2 minus 2, 0. 5 minus 4 gives you 1. So the remainder here is 105. So what is the HCF? The remainder should be 0 and that divisor will be the HCF. That's how the Euclid algorithm says, right? So let's divide this 105 and 315 again. So 315 divided by 105. How many 105s will go in 315? Let's do 3. So 3 into 105 gives you 315, right? So let's do the subtraction. 5 minus 5, 0. 1 minus 1, 0. And 3 minus 3, 0. Now we got the remainder as 0. So this divisor 105 is the HCF of 210, 525 and 315. So I hope this is clear to you. We have a few activities to be completed today. You have to do the target Olympiad from page number 15, speed maths, fun with maths in the same page. And in the target Olympiad, you can see 2 numbers. The first question is find the values of A and B if the given number 7A, 5, 7, 9, 8, B8 is divisible by 33. See, you are given this A and B here. You have to find out which numbers will come in place of A and B. And you are given this whole number is divisible by 33. How do you find that? See, when you say a number is divisible by 33, it should be divisible by both 11 and 3. Why? We can write 33 as 11 into 3. So if this number is divisible by 33, it means it should be divisible by both 11 and 3. You can apply the rules of divisibility for 11 and the rules of divisibility for 3 in this case, and you can easily find that number. Now the second question, John has some marbles. If he arranges them in groups of 5, 4 are left. If he arranges in groups of 4, 3 are left. If he arranges them in groups of 3, 2 are left, and if he arranges in groups of 2, 1 is left. If the number of marbles with John is less than 60, then how many marbles does he have? So you are given some clues in the question, and it is said in the question that the total number of marbles he has is less than 60. Keep that in mind. And he can arrange these marbles in different ways. He can arrange them in groups of 5. Means he can arrange them in multiples of 5, like 5, 10, 15, 20 and so on. So in the end, which is the multiple of 5 which is less than 60? The closest multiple of 5, the multiple closest to 60 of 5 is 55, right? And when he arranges in groups of 5, at the end 4 will be left. So this 55 plus that 4 left, how much is it? It is 59, right? So you try the different arrangements, try arranging them in groups of 4, 3, 2 and see when you add the remaining marbles to the last multiple, see if you are getting the same number in all the cases. If you are getting the same number, that is going to be the total number of marbles that John has. And in speed maths, these are 5 very easy questions. You can note down these questions in your notebook and do the answers. And also, it's a fun crossword. And in this fun crossword, the last one, question number 5, HCF of two numbers is 3 and their LCM is 36. What's the product of two numbers? We have already seen this, this method in this class. So you can apply that rule here. And there are a few more activities in the next page, page number 51, Maths Game, Maths Lab activity and My Project. Please go through them and do accordingly. So that's all for today. We'll meet in the next class. Until then, bye.